Welcome to today's weather update on Tyler's World of Weather. And this is a non-scriptural update. In other words, I don't have a prompt or a teleprompt or anything like that. I am just going to give you what I have. So let's check out our Jamstack weather model and see what that has, if it's out yet. And it's not. That always puts a bump on my day. Let's take a look at Weather Bell. I'm going to take a look at our 45-day outlooks and off our European weeklies. I'm going to go to our winter snowfall. There's quite a bit more snowfall now. I don't know if you perceive it, but there is quite a bit more centimeters of accumulation there. We're in snow season. You could call this winter. We're in winter in that sense that we're in the snow season now. Okay, it's kind of happy to me. And taking a look at our 46-day temperatures, which will kind of... Okay, so again, a lot of warmth towards the Gulf states, extends all the way up to Canada. And I have to address a subscriber who said something that was inaccurate. He said that if there's warm air in Canada, you have no cold air for the USA. But that's totally opposite of how the actual pattern works, and I'll get into that right now. We're going to take a look at our upper air pressure heights, 500 millibar anomalies, 30 days. And we're going to take a look at this. I will show you how it works in the 500 millibar layer of our atmosphere. Okay. So first of all, we're going to take this on a global scale. It's more important for this update because we want to look towards winter. Okay, global 500 millibar heights for the next 30 days. Notice we have a trough in the northeast and a lot of ridging and warm air in the USA and in Canada. Okay, so what does that have to do with having cold air in the USA? Now you might look at this and say, well, he was right in saying that, but I would say in response two things. One, this is a summertime pattern, not a winter time pattern, so it's kind of non-relevant. But I would also say that when you do get blocking strong enough in the North Pole, then you kind of recreate a certain trough in the USA. So again, it's completely opposite of what you said. And in order for us to get a cold and snowy winter, this is just facts now, you need blocking in Canada and high pressure and warm air. His comment was that then you won't have any cold air in Canada. Well, in response to that, I have another two things to say. In Canada, during wintertime, it's always cold. I don't care if it's a little heat wave there in the winter. You're going to have negative 20s and 30s in Canada. The farther north you go, negative 50s. Canada's cold. So we don't have to worry about Canada being warm, too warm to give us cold. Okay. That's what I would reply back first. The second response I have to that is, so when you get a block in the North Pole, that creates cold air in the USA, because it creates a suppression. Dense cold air. Cold air is always more dense than warm air because the water molecules are flowing faster. In the atmosphere with warm air, you have more kinetic energy, whereas in cold air, you don't have kinetic or potential energy because it's dense. It has no energy. You don't really have an MJO pulse there either, but that's a whole different story for another different video. So with that being said, I want to look at so that's the best analogy I can give off that without going into much more detail. So bottom line, yes, you do want ridging in Canada to get USA cold. Okay, now that we've covered that, let us take a look at our NAO, our North Atlantic Oscillation, which is currently very strongly negative, very negative. With that being said, it's forecasted to spike positive in the next 2 weeks, but then go negative again. Looks like a negative NAO starting to develop for winter is what I would say. Looks to me that way. Let's take a look at our NOAA MJO and going to do a little hint on the MJO on the velocity potential on the infrared satellite, and where you have these green contour lines, that's where you have an active energy MJO pulse, okay? The MJO is all about energy, where you have a non-active MJO, you have dry air because you have no energy and you have a lack of weather that is active, like blizzards or storms or what have you, because there's simply not enough energy in the atmosphere, which is why the MJO is a big factor, because it kind of is the foundation for every other factor, because energy is what weather uses to work with. Okay, so you can see where the MJO is at right now. It's in the where it should be, actually, which makes perfect sense. It's in the equatorial Pacific, where we have all that warm water off the El Nino, creating that energetic pulse. Warm water creates lots of energy in the atmosphere. Okay, let's take a look at our El Nino currently. Here is our sea depth anomalies, and going all the way until August 6th. Get ready. We're going to see a big boost in warm waters in the eastern Pacific. Get ready. Look at all this warmth. Niños 1 and 2 are going to spike in a dramatic way. Okay? So, what I believe is that as Niño 1, 2 spikes, it's going to transition west towards fall and winter, and we're going to have a Molokai centralized El Nino. Okay, so that's my prediction on that. And with that being said, why don't we take a look at, I'm going to go for our Jamstack forecast for winter. I believe this is the most accurate model we have in terms of at least very bare minimum of the sea surface temps anomalies. That's a Molokai, that little signature off the ENSO. That's a Molokai ENSO right there, okay? Very, very polarized in the Central Pacific, centralized. That would produce what we're about to look at, which is our 2-meter air temperature anomaly. Lots of cold in the southeast.